The emerging pollutants. Technopolo Bologna CNR promotes innovation in both consolidated and emerging industrial systems, and it hosts 2 industrial research labs. What are emerging pollutants? Are the source chemical, synthetic, or natural that have recently been disclosed, but for which the risks for the environment or public health have yet to be established. Examples of emerging pollutants are heavy metals such as lead, mercury, chromium, medicines, but above all synthetic substances mainly used to make various materials. The removal methods tested at CNR use ultra and nanofiltration membranes. But what are these principles based on? Nanofiltration is an innovative separation mechanism that uses membranes with pores smaller than those for ultrafiltration. It is a technique used for the treatment of liquids with a low percentage of suspended solids. It is used in softening, desalination, and other wastewater treatment operations. Ultrafiltration refers to membranes that fall within the pore range of 0.01 pm to 0.1 pm. They have pores small enough to be able to retain, in addition to large particles and microorganisms, also bacteria and sublevel macromolecules such as proteins by exerting higher pressures. But what is the separation method used? The separation is mainly obtained through the absorption of pollutions on the membrane surfaces. What is ultrafiltration used for? It is often used for the treatment of domestic and industrial wastewater or for the recovery of processed water. An example of ultrafiltration carried out at CNR was the filtration of water containing rhodamine, that is a fuchsia dye. First, polysulfone membrane fibers were ground into a fine powder, which, when compacted in a plastic tube, was used as a filter to separate the rhodamine from the water. By implementing the nanofiltration process, the CNR wanted to highlight the difference in the effectiveness between 2 identical processes that, however, use different materials. In fact, the same quantity of water and rhodamine was inserted into 2 test tubes containing, respectively, activated carbon and graphene oxide. By shaking the 2 test tubes, it was possible to notice a better separation by the graphene oxide compared to the activated carbon, since graphene oxide has an adsorption surface more than double that of activated carbon. So, why not replace activated carbon with graphene oxide? The answer concerns the cost of graphene, which is too high compared to activated carbon. In fact, at the same cost, a much higher quantity of activated carbon is obtained than of the graphene oxide.